Thanks for coming, and I changed a little bit my title's talk because people were expecting me to give tutorials on how to use some particular libraries. So I think it's a little bit about that, but not exactly. Today I'm going to talk, half of the talk is about how to design things, and half of it is about what to expect from mocking libraries. So that's the idea. And before we go into this, I want to learn a little bit about you. How many of you are Java developers? Cool, so everything will be easy to understand for you. I even will speak a little bit about Ruby, so don't worry. Okay, so first of all, why I do this talk? Because, you know, I tried testing, manual testing, I didn't like it. Then I said, like, what can I do about it? So I started to write unit tests. And then I found out about mocking. And, you know, mocking, who likes mocking, by the way? Okay, so you're lucky. I hate mocking. And that's why I'm giving this talk, because I think I hate mocking because I had so much time that I spent debugging my test because of mocking. And I really want to share some experience with you for the things that I didn't know before. And so I will talk about frustration. I will maybe cover a little bit. Mocking is bad. Like, this is like that motivation that people say, okay, mocking is bad. And mocking is bad because, you know, I get frustrated. Many of you get frustrated. And maybe some of you like mocking and then abuse it. So I don't think that mocking is particularly bad, but maybe it exposes some design issues. But let's see. And wasting time debugging tests. The whole premise with test-driven development, for example, is that you should get instant feedback, and that feedback should stop you from learning how to use debugger. That's, for example, what Uncle Bob says. And another thing that I really want you to take away home, don't use libraries, tools, frameworks religiously. For example, if I'm front-end developer, there are other tools than Angular or React or something. Just learn our things. Try to understand what's going on with them. If you're Java developer, who will use Spring for their applications? Come on, most of you. But do you know any other alternatives for Spring? That's great if you know, but if you don't, this is your homework after this talk. Sorry? Yeah, that's a troll in the audience. Great. Okay, so I'm not saying that those tools are bad, but you need to understand what to expect from the tools, and you have to challenge those tools. Don't let tools challenge you. Okay, so, and for example, if I mentioned Ruby, I will mention it again. If we speak to typical Ruby developer, they will do everything with Rails. I think we shouldn't end up in such situation. We should question what we do. So, agenda for today is why do we care about mocks? This is more about like theory part in this talk. Then the most important one, I will show some examples with Makita, JMock, and which also apply to our JVM libraries. And what I really want you to remember is the content of that second part, because I think most of you don't know this. I also didn't know it for maybe 8 years of using mock libraries, and then what I did, I just finally tried different tools, different languages, and I realized that how stupid I was. So this is about that, and I hope you'll learn something new. And I did one thing, like in the end, like that frustration with libraries led me to a situation that I said, okay, probably I can do it better. And it turned out that probably it's not the case. So what I did, I wrote a small, simple exercise at home during Christmas time, and I wrote my own mocking library. And I will speak a little bit what are the challenges writing mocking library, and basically what are you trying to solve by doing that. So it's like getting into the boots of mocking library developer. A little bit about me. I organize Vilnius Java user group, but I don't do Scala for more than 3 years, which is like a shame. I still like Java a lot, and I think like it's especially the platform. I can do full stack, which means that you just need to know JavaScript and CSS. That's what it is. I'm a huge TDD enthusiast and mostly care about software design. That's why I do this talk. And I have this slide because I want followers on Twitter, where I mainly tweet something that I hate or just like random quotes that I come up myself. So you can reshare or something. So let's talk about testable design and why do we care about it. So as I told, I hate testing, so I decided to automate. And to automate stuff, it's not so easy after all, especially if you write tests after you have production code working. And testable means that you can split your system into components and verify if they work correctly. Design means that you are able to change that software in the future easily. And putting those things together is a valuable thing. And if you want to dig more into this thing, I really recommend to start maybe with this book. And it's like a challenge for you because I had to overcome this myself. To read Ruby book by being Java developer, it's like a mental shift. So go out of your comfort zone. By the way, who of you know what Sandy Metz is? So go home and watch her videos. She's very good on software design. I think Yegor mentioned null object pattern. She has a talks on that. So go and watch it. Like she's more on design than Ruby, and it's a good book to escape your comfort zone from being only Java developer. And today we're full stack developers, so knowing our languages like JavaScript, it's a good thing, and I think this is like a good compromise to learn about design. And it's not only about object-oriented. It's more about design with some examples in Ruby. And what's nice about it that like Ruby is not static language. So not being dynamic language brings some challenges, and you can see how those challenges can be solved by designing software. And what is object-oriented design? I would put away object. I will just leave what is design, and it's about managing dependencies. And dependencies are something that we should care for one simple reason. If I have to add feature to one place of the code, I don't want to change my dependencies. I want to have a cohesive place to introduce a change. And this is what design tries to solve. It's not about making code beautiful. Beautiful is something maybe what pleases me, but in the end, a company product doesn't benefit from it. And as I said, purpose is just to allow you to change, add features later. And this is a wonderful quote, and I think this tackles what design is. Another great book that I recommend reading is Growing Object-Oriented Software Guided by Tests. You can delete that last part, guided by tests. It's about growing software systems. So this is how to solve many different problems that happen along the way you develop. And what they say about design is that design is about things that happen between objects and not about what's inside the object. Inside is something that is your own problem, but usually systems are composed of multiple components, and they break. And the biggest challenge is to make stability between those connections between objects. another thing what they say about design is that interface describes if two components will fit together, which means like I have one thing and another thing. Both are objects. They have no behavior. If you can connect them, that's it. That's what interface does. And from design's perspective, what is more important is that you need to understand if those things will work together. For example, if you put tire on the car, does that tire actually fits that sports car or no? Like, can it handle the speed and so on? So this is what protocol is. So you should, when you design Java systems, you should think more about behavior than if things fit together. Okay, so let's talk about testable design. So in the middle of this picture, you see one thing where on top it's written mocks. So mocking is about mocking your own things. So this light blue area is where you develop your business logic. And you try to put everything that is not yours to the boundaries of that logic. And you guard yourself from that world which is not yours by asking to provide protocols. And for those protocols, you write your own adapters. So this way, you make one interesting thing that you don't need to know which database you use. You don't need to know which UI you use. Maybe that's like testing UI, which is like a fake JavaScript engine or something. And mocking happens inside this circle. You can also, and question is, what do you do about those parts that are outside the circle? And for those parts, well, you cannot mock those parts because something which is not yours, you never can be sure how it works. So what you can do, you can only integrate or you can end-to-end those parts. And this architecture or design is called ports and adapters. And idea behind it is that application should be equally driven by things that you don't know, like from the outside that exist. Like your application should be written so that you don't leak into your domain logic any details from the outside. For example, if you need storage, you don't care about what type of the storage it is. Maybe that's a storage which doesn't store anything. It just like sends your data to some another storage, like a proxy. Or if you have a user interface, that user interface can be browser, can be test, can be something else. And this architecture also known as hexagonal architecture. And you may ask, why the heck it's called hexagonal? And I will quickly explain why. So let's say we have application. So this is where we write our business logic. For example, we can be a bank or maybe some other software company, as it was told in the morning that everyone is actually working now for software companies. And this application doesn't need to know about MySQL. And you see this hexagon lets you visually put another hexagon side by side. So this is the answer why this architecture is called hexagonal. And another interesting thing happens that MySQL is again another application, and for MySQL this application looks exactly as like a known thing. It just provides some port which you implement with adapters, and that's the way you separate yourself. And going even further, like we can add JavaScript UI. By the way, those ports are usually called, they have two types, but it's not very important. One type is primary. Primary is user interfaces, and secondary are storages, queues, or whatever, emailing systems, and so on. So for JavaScript UI, we get into the similar situation. We can write single page application. We can test it in isolation without even knowing what our backend is. And if we want to test backend, we can create acceptance test suite, which doesn't know about JavaScript UI anything. And application doesn't really care where it's like a real user interface or is it like a test that we have written. All right, and in production, we can automate some production test cases and have smoke tests running. So this way we have like hexagons that do not know about our existence. They just communicate over protocols. If we are Java developers, those protocols can be interfaces, but they don't have to be. It can be network, it can be HTTP or something like that. And for example, the last example, backup service. It really doesn't care about this application, but what we do, we actually backing up data which was collected using this application. So this is the point of hexagonal architecture. And now it's a perfect time to start talking about mocks and show you some code. Okay, so I will speak about Makita and JMock, and my goal is not to blame someone or say that those libraries are bad or good at some points. I believe that both of those libraries are like really good and they do job if they are used correctly. So let's start with Makita and look at simple example. So idea is that I specifically skipped additional lines so that you expect something to appear here. And what we are going to test, or what is our system under test, is sales reports, which will depend on finance. And for dependencies, we will mock those dependencies. And by the way, anyone doesn't know Makita? Okay, so a simple idea is that you just get static helper mock and you pass a class name and then you have a fake finance or your class instance. And then you can tell how this fake instance will act upon some situations, and we will see how to describe that later. So basically what Makita and some other frameworks let you do is to, instead of forcing you to implement that interface separately from your test class, you can implement that class using proxy by just using nice DSL language in your test code, and sometimes abuse it. So my question is, what will happen if I run this one? Of course, you don't know what happens under the hood, but what is the most typical situation? So the most typical situation is that if I pass a mock, probably something will be called on that mock, and if you do that with Makita, you end up with null pointer exception. And sometimes if your tests are written in the way that they are very complex, they use complex collaborators, it can be a nightmare to debug them, especially if they are not unit tests, but some integration tests that depend on many things in the system. So this is the problem that I hate the most. Like, it's a consequence of something that I don't know what. I just know that my test doesn't work. It doesn't explain what is the cause of it. So to fix this, well, we're fixing null pointer, but not fixing our test in the way that it becomes better. So what we will do, we'll just add a stub. What stub? And some people call this mock, but this is not mock. It's just like stub, which on this call with this parameter will return this value. It's not mock. I will come back quickly what mock is. And if I add additional verify statement, that stuff turns into the SPI. And SPI is something that you run the system, it finishes execution, and then you can do postmortem analysis what happened with the system. And according to that analysis, you can say that, okay, my system works or it fails. So you can feel that things happen after you run the system instead of saying what you expect to happen before you run. So this turns, and to catch null pointers, most of the time you need to look into stack traces or maybe to run debuggers to understand where the heck I lost my value and what was called. And it becomes a bit harder if you have a lot of mocks. Okay, so let's look how JMock handles this situation, and pay attention a little bit about the syntax, about how natural those frameworks look. I think Makita looked pretty natural. Its DSL is very well understood and it's easy to write it yourself. Again, I have something missing here and we will add it later. So the same situation, the same finance class is dependency for sales reports, and when I run it, it says, okay, finance is not an interface. What does it mean? It means that JMock doesn't know how to make mocks out of concrete implementations, which did just work fine with Makita. And some people think that this is a good way to go, and I think many of us, especially who are in design, we think that we should split interface from implementation, and it will definitely bring some good, potentially for the future, it will be easier to change. But I think that we have such a wonderful tools nowadays that it's much easier to factor out implementation from existing concrete implementation than to start separating interface from implementation from the beginning. And if you start doing that, there is an obvious problem. The problem is that you need to come up with two names, one for the interface and another for implementation. Of course, those people who are into design, I think they are completely right, because if you start from the beginning extracting interfaces, they have one thing in mind, which is that you change dependency from implementation into interface, which decouples your user from implementation. But sometimes you don't need this, especially if you have single implementation. You don't use any, I don't know, RPC implementations or something which requires you to give away API separately from implementation. So I would say that you should decide yourself. I usually try to extract implementations later when I get a feedback that I need them. And on the other hand, from customer's point of view, if I get a class, I usually don't care, is it an interface or implementation? Every implementation has public methods, and those are imaginary interfaces that I only can call. And don't forget that we care about works versus fits together. So interface only will guard you from fitting. Okay, so for JMock, there is definitely a solution. You just tell in an ugly way that you are going to allow mocking finance like concrete implementations. That's ugly, but that's a solution, and probably you can factor it out into something more beautiful, but that's not the point. And when I run this code, now I get another thing which I actually like. What it does it produces a report which says that it just received unexpected invocation, and if you have multiple of such lines, it will clearly explain what happened before and what it is going to expect. So I think this is a good plus from mocking libraries, and this is where mocking is different from spying or stubbing. Mocking sets expectations, and mocking is about expectations. And expectations, if they fail the whole test. It's not about looking into postmortem result, trying to catch some null pointer exceptions. Okay, so again, another ugly part is how to write the same expectation that we know from report that we are missing, and this is how it's done. It's an ugly old implementation. Probably some junior programmers wouldn't even know what those two braces mean here, and this is another homework for you. So it's also a bit ugly because to define one stub or mock, you need to write, in stub case, you need to write two statements and not mess around with them. Okay, so I think Makita has very nice DSL, and JMock does mocking right, but JMock just looks a bit maybe old, I would say, or its syntax is very verbose. And it also breaks given when then style. If you look back, you see I set expectation, but I don't assert anywhere that such thing is required for my thing. So this breaks given when then because I only give and then happens exactly at the same time where I'm giving. Also, when you expect and require something to happen, you are in the risk of overspecification. And if you overspecify something, it may be a smell that your design is too complex and you should just change your design, listen to a test. And also pick one, verbose or implicit. And Makita does many wonderful things by not telling you that it's doing that. And the same happens with JMock. And this is the problem. Like we have either very verbose syntax or we have to do things implicitly. Okay, so what happened with Makita? I created stub, I executed it, then I had to debug nulls. I needed to understand where the null pointer came from, and then I had to repeat until I make my test work. What happened with JMock? I set an expectation, I executed my system, then looked at the report that something was wrong, and according to that report, I fixed the test. Looks very similar, but one works on the actual result of the system, another works on the actual result of the test, which is very important difference. So, what is mock? Mock is an expectation set before exercising system under test. And spy is something that you look after you have exercised your system. So it's an important definition. And one more thing, you can also set expectations with Makita, just many people don't know about that. And because it's very hard to find out that such feature exists, nobody uses that with Makita. And J.B. Rainsberger has a strong opinion on spying and stubbing, and he says that both of those things are actually synonyms, and they solve idea of something that I call myself of patching. So, for example, if you need something from dependency, you provide a patch and see if that works, but without really knowing whether it was a correct patch. And what community says about it? Community says one thing, again, this book that I recommend to read everyone. So one thing is tell don't ask style. Tell don't ask style says that you should send commands to objects or send messages instead of querying them for data. Well, if you do functional programming, it may not be the case. And I think authors of this book also have slightly changed their mind, but I think it at least forces you to think about some object thinking ideas. Another thing, only mock types that you own, which is the idea that you can mock or set contracts on things that you can control. If you mock stuff that you don't own, how can you be sure that your mock is correct? And don't mock values. If you need to mock values, it means that your value is too complex. Just simplify design. Another approach is Lenient Approach, which is promoted by Spock. And I think that Lenient is equivalent to spying. So some community believes that spying is still better. I believe that strict behavior is a bit better because it quickly gives you feedback. And I think testing is about quick feedback. It's not about getting information that your system works. It's sometimes more important to understand what doesn't work and what you need to fix. It's about the time that you save by having automation test suite. Okay, so I had some time during Christmas and while visiting families and so on. So I decided to play an exercise and to write my own mocking framework. It's not for real use. It's just like you can find it on my GitHub, but it's just like an exercise. And it's good exercise like a kata. I also wanted to understand why the heck authors of those libraries did things that so much annoy me. So I tried to avoid those problems. Also wanted to understand if use of Java 8 features will improve mocking syntax. And another maybe less important thing, I wanted to find a project where I can use some code generation and learn JBody. Okay, so the idea is that I had to unlearn what I already know and start from scratch. So my goal was that API should be explicit. It shouldn't have any surprises. With JMock, with Makita, you can quickly get into surprises because Makita is not thread safe. It does things that you don't expect sometimes. JMock definitely very explicitly says that it depends on the order that you specify your expectations. So this is what I came up. And idea is that you create mockery. By the way, JMock does the same thing, but if you run with JUnit, there is an integration which can hide this boilerplate that we have here. And I pass my collaborator class, which is like in previous example, it was finance. So I create mock by just passing a class and get a proxy object and then set expectation. And I have two types of expectations. One is command, and another I will show in a minute. So I wanted to have more succinct syntax, but I couldn't come with better one. So if you know something that could improve this, you can come up with a pull request and send it to me. So idea is that I pass collaborator, and then I said I want to mock a command. Command is something that doesn't return result. It just accepts a call. And that command takes lambda, and that lambda knows which methods our collaborator has. Why this syntax? This syntax is important from the IDE's perspective, because this one is very well checked by IDE and by the compiler. And then you call a method, and if you call exactly what you mocked, what you expect, it will pass. And then if needed, you can call optional verify. In case you didn't call anything, you may want to call verify. Very similar with querying. Querying is when you return value, or in Makita case, it would be stub. And you say, okay, I want to query. I want this query. And when this query comes, I will return this. Again, this syntax is what I come up if I want to have IDE to autocorrect me. And how it works, you just call the same way as previously, and then if needed, you can verify. So this is the API. It's very simple, no hidden implicit ideas. It's still not thread safe. In theory, it's not thread safe. You can come up with some race conditions, but it's easy to fix that. And to implement a Mach, I used JBody. And JBody is a very nice library. I think from usability point of view, it's probably one of the best. I still would say that docs are not the best on the market, but as long as you try to do something and find out the way how to do it, it's very obvious what's going on and easy to use compared to our libraries if you have used before. Also, Googling helps a lot. Author of the library is very active, and probably you'll get your question answered very quickly. So how does it look? So you have you call ByteBody, you pass a class that you want to mock. So in my case, it would be collaborator. And you tell, okay, I want to match all methods, for example, in my case. And then I say when this method is intercepted, just send information to Delegate. So basically, it takes all the parameters and all the call information and transfers to Delegate method. And when you say get loaded, you basically create a proxy class. And then what Delegate does, it has many annotations, which are, I don't know, probably they reduce boilerplate, because otherwise you will have to have a lot of parameters and then specify those parameters that you are not using. But anyway, I think this was the hardest part that I spent my time on, trying to understand which parameter works in which condition. And okay, so this is my delegate. And I then return, I intercept invocation, and then I pass it to my own class, which is not specific to ByteBody. It's not annotated like that and so on. So this is where my own code starts, and I'm not showing it here because it doesn't do anything very smart. It just like stores parameters and methods in some form, which I later can find when the call happens. You can look it on the GitHub. So, what are some challenges and things that stand in the way? You can only mock method calls with this approach. Otherwise, it will be very hard and not easy to change bytecode for fields and so on. So it's doable, but I didn't want to go there, and none of the mocking frameworks are doing that at the moment. By the way, if you have any questions, just feel free to ask. So, for example, this one it can be mocked because it's a method call. But this one is a field and it's not supported. I think it can be done in Scala, but because in Scala it's different, Scala does it differently, and in the end it's still a method. Another thing is what I wanted, what most frameworks don't do, is to report if I specify a mock and that mock is a nonsense. So for example, I do not do anything with a mock, and I may consider that I set mock properly. So I want this command failed even before going into actual execution of the system under test. And it will throw a method. It will throw exception, which will explain what is going on. This is another thing that I wanted to do, reporting to be as precise as possible. Okay, so one thing that I would probably improve here, that currently it's strict order. It works most of the time, and maybe it's a a good way to debug your tests, debug your production code, but it implies some imperative knowledge about your code. So your tests hard code in things that happen in your production system. So currently it's strict order, but it's very easy to add something which doesn't care about the order. And verifying stubs is another story, but for example, if you want to have a stub which can be called multiple times, then such feature probably should also be added. But it depends. Like I think that most of the code that I write doesn't require those features at the moment. Okay, and reporting is something that should be first-class citizen in mocking framework, and I think this is the most important part, and I mainly copied it from JMock experience and added some of the corner cases that I experienced myself. By the way, JMock has a very strange naming strategy, which looks like if you name if you name your variables according to the class name, just by lowercasing first letter, it looks like JMock somehow knows about the name of the variable, but it turns out that this is only a strategy inside JMock. And this looks very similar to what I have in JMock and in JInsist. So I was very much inspired. So where does it fit? Where does such approach fit? It doesn't fit to legacy code testing, because the idea behind my implementation was to make test feedback as important as possible, and it's very strict. So it works well with test-driven development. It works well with new code that you write. And another thing is that I wanted to have very simple framework, which turns out, to summarize this talk, that when I looked first into what Makita does, or JMock does, it turns out that they have very large code base. Makita has a lot of code, and JMock has a little bit less, maybe because it's less used compared to Makita. But still, like I couldn't imagine that those frameworks have so much lines of code. And I think Java 8 features helped me a little bit to improve syntax, but still Lambda syntax in Java 8 is a bit verbose. Hopefully in the future underscore will solve some of those problems. And the main takeaway from this talk is that use existing tools, but you need to understand where are their limitations. And I think I spent too much time just debugging my software without having a proper tool which tells me what's going on in my code. And I want to say thank you, and do you have questions? It's time to wake up.
Just a small one, not really a question, but I want your opinion on integration tests.
So integration tests, like if you look into testable design idea, which ports and adapters, like something that you integrate with, like for example, database, you have to test only with integration tests, otherwise you're not sure if they...
So you wouldn't test mock a database call?
No. I would mock a protocol or interface which I own.
Can you talk a little bit about why you can only mock things you own?
The main idea is that if mock brings something that you create yourself, and mock is a contract that you described yourself. If you don't control a thing that you're using in your code base, there's very little like point to mock it, because if something will change, your mock will be incorrect. If you have something that you control, you can at least be sure that you're using the way that you are that you were intending it to be used. That's the idea that don't trust third party. So that's the point. So, and mocking only helps with interface, or it doesn't guarantee that internals will change. So mocking works very nice inside your own domain, inside your own business logic, because you have at least tests for implementation, and then you have tests for the user of that class, which can then be injected with a mock.
So from third parties, you expect to get test kits, right, or something to test it with?
I'm not really sure if I'm a huge fan of test kits, because test kits may bring a coupling problem. I think what's really nice that what I want from third party is a good protocol. So you bring a well-defined API, it's clear, expressive, and then I can rely on you, rely on you, rely on you, rely on you, rely on you.